Right, class, this is 12C. We're doing apportionment and talking about mostly the House of Representatives and then some other things that like class sizes and different things, who represents who and for how long, well, not how long, but how many representatives will be representing a certain body. Each state, as we know, in the United States has 2 senators, but the number of representatives varies from state to state. So with the senators, we just give 2 per state, but the House of Representatives is a little bit different. There are 435 seats in the House of Representatives, and as we know, there are 50 states, and so each state gets a certain amount. Now, this question, the question of how many does each state get, is one of apportionment, because the seats in the House of Representatives have to be divided up among the states in a fair way. In this unit, we're going to discuss the mathematics that are behind apportionment and how many representatives are going to represent each state. Article 1, Section 1 of the United States Constitution says, all legislative powers herein granted shall be vested in a Congress of the United States, which shall consist of a Senate and House of Representatives. So for the United States House of Representatives, apportionment is a process used to divide the available seats among the states. So more generally, apportionment is a process used to divide any set of people or objects among various individuals or groups. And this process of apportionment we're going to study. First thing we need to figure out is we need a standard divisor and a standard quota. Now, the standard divisor is the average number of people per seat in the House of Representatives for the entire population of the United States. So the standard divisor tells us what average number of people will be represented by each seat. We look at the total U.S. population, all of the population, and then we divide that by the number of seats that are available. And that gives us the standard divisor. Okay, that's the average number of people in this per seat. The standard quota for a state is the number of seats it would be entitled to if fractional seats were allowed. And that's the problem. Once we get that standard divisor, if we divide the population from each state by that standard divisor, that should tell us how many representatives we get. However, if we have 435 seats and we do all the division, we add up all the House of Representatives that would be representing each state, then say we have 435, maybe we'll get 430 total. Now, the trick is, well, what happens with those extra 5? Who do we give the extra 5 to? And luckily, the rules of mathematics and apportionment help us to determine who gets those 5. Do we give one to South Dakota? Do we give one to Vermont? Do we give one to Maine? Do we give one to Utah? How do those 5 go? And luckily, this process is very helpful because once we've figured out the standard divisor, we've divided the populations in each state by the standard divisor, and we've come up with each state's representatives. If we don't quite have the 435, then apportionment allows us to figure out where those 5 go. All right, so this can also apply to any apportionment problems besides that of the House of Representatives, but majority of what we'll be doing deals with the House of Representatives. This one, though, does not. A small school district is apportioning its 14 elementary teachers among its 3 elementary schools, which have the enrollment shown in the table. Find the standard quota of teachers for each school. So in looking at this, I'm hoping, you know what? I am going to pause for a second and figure out how to write on this, and then come back. Hold on. All right, I figured it out. Sorry, I got a new toy here and I'm trying to use it, and I forgot that I have not yet written on a PowerPoint, so now I'm writing on a PowerPoint. However, I do not know how to erase, and I just tested it in a silly way, and my apologies. I'll fix that. Okay, so a small district, we're trying to figure out how to apportion its 14 teachers among the students there at the 3 elementary schools. So Here are enrollments. Now we have a total of 48. So the first thing we're going to do is we're going to take our total, and knowing that we have a total of 14 teachers among these 3 elementary schools, we'll take the total enrollment for each of the schools and divide it by the total amount of teachers to determine how many teachers we should have or what the standard divisor is going to be. So 448 divided by 14 is going to be 32. So our standard divisor is 32. All right, so now we're going to take, for the standard quota, or how many teachers should go to each school, we're going to take the population and then divide it by our standard divisor. That tells us we should have 1 teacher per 32 students. All right, let's see, 197 divided 32 is 6 point, so I'm going to write 6.15 here. Or actually, it should be 6.16 if I round up. And then 106 divided 32, and that's 3.31. And then 145 divide 32, and that is 4.53. Now, the issue here is when we go ahead and figure out how many teachers should be at each of the schools, we round down. So we should just have 6, and then 3 for Lincoln, and 4 for Roosevelt. Even though Roosevelt is 4.53, which would normally round up to 5, what we always do is round down. So if we take 6 plus 3 plus 4, you're going to note that we have 13, right? And 6 and 3 and 4, I'm just going to write this above here. If we round appropriately, gives us 13. However, we had 14 teachers. So even though our schools don't have that 32 students equally, like Washington doesn't have a multiple of 32, and Lincoln doesn't have a multiple of 32, and Roosevelt doesn't have a multiple of 32, so everything works out nicely. Generally in life, things don't work out so nicely, and we have 1 extra teacher, which we have to account for, can give to a school. Now, what they do with that is we round down to start, so that's why we got 6, 3, and 4. And then once we've done that, we count our total and judge it against what we do have, which is the 14. And then we determine, well, we need 1 more. And then we look at these decimal, the parts of that of the standard quota, and we find the biggest of the 3, which is 53. Whichever one has the biggest portion of the standard quota, then we add 1 more to that school. And if we had 3 more to distribute, we would find the top 3 are the highest dividends. And in this case, it's going to be just 1. But anyway, if we have 3 extra, we don't just give all 3 to Roosevelt because it had the highest decimal. We give 1 to each of the top 3. But in this case, we had only 1 extra teacher not accounted for. So Roosevelt, having the highest decimal, 0.53, then they get the extra teacher. So then we have 6, 3, and 5, which is a total of 14 teachers. All right? And that's what apportionment does. First, we find the standard divisor, and then we divide that into each of the populations, and we come up with a standard quota. We round down on the standard quota to get a base number of, in this case, teachers or delegates or representatives or whatever they are. And then we determine how many more we have available to represent than we are actually given. And we add those to the highest of the decimals after rounding down from the standard quota. All right. And that's the trick. All right, I think we can do a couple more problems, and then I'm going to have to divide this lesson into two. And I just need to find where my mouse is. There it is, so that I can move over. Okay. This just goes through what we did, so we'll just move on to Hamilton's method. So Hamilton's method, after finding the standard quota for each state, then there's this method involved, which is Hamilton's method, that allows us to come up with the number of representatives in the fairest way possible. Now, there are a lot of different methods to do this, to find the representatives for each state. Hamilton's method is the one we use, and it's the most popular of them. We're going to talk about it, we're going to try a few, and then we're actually going to talk about a paradox that could happen and has happened in the past, and the workaround for the paradox. Well, not really the workaround. We're just going to show you when that occurs, and then we'll move on from there. So after finding the standard quota for each state, to find Hamilton's method. So this is that last step that we're talking about in the last problem. Standard quota means that first you give the state the number of seats found by rounding its standard quota down. And again, this is exactly what we just did. I'm just going to go over it. Oh, I thought that would be different. Anyway, you round down. This number is the state's minimum quota or lower quota, right? Once you round it down. That's why we had 6, 3, and 4, I think it was, or whatever it was. It's because that 0.53, no matter what it is, even if it's 0.99, we still round that standard quota down. And then if there are any extra seats after each state has been given its minimum quota, we look at each state's fractional remainder, that decimal that follows, that fraction that remains in the standard quota after subtracting the minimum quota, and then we give one each of the extra seats to the states with the highest fractional remainders until the seats are all gone. So we just go one by one. We give one to the highest fraction. We give one more to the next highest fraction and one more to the next highest fraction until all the seats are given. Now, the Alabama paradox is a problem sometimes. That occurs when the total number of available seats increases. So say we had 433 representatives, and then all of a sudden we decided, we're going to just increase to 435. Or assume that we have 100 delegates, and then all of a sudden we're going to change to 101 delegates. Now, if at 100 delegates, each of the states gets 10, okay, and each of the states get 10 representatives, and suppose then we add another delegate, we get one more, so 101 total delegates, and then we go through and figure out, using the Hamilton method, which representatives go where. And we have, in the end, 2 of the 10 states had 11 representatives, or should get 11 representatives, but 1 of the states went down to 9 representatives, so they lost a representative. Then the Alabama paradox has occurred. That means a state lost a representative by adding one more representative to the group, to the mix. And that's not good, because that's not fair to the state that lost a representative when one more was added to the pool. And that's the Alabama paradox. So anyway, you'll have a couple of questions like that that ask about that on your homework. And we're going to go through a couple problems just so that we can understand this completely. And I think we're going to start right here and do the next 2 on the next lesson so that I keep it under the 15 minutes and it loads properly. So I'm sorry about that, but we'll start right up. So just click on the next slide or the next video that's available. Thank you.